It's Mr. Benson here with the final video, which is the solutions to the level 9 stuff from the CAT. So again, stuff's getting a little bit trickier, but a lot of it is just formulae that we've gone through, so stuff that isn't really new or too difficult. There's one or two questions in here that are definitely a little bit harder because you've got to think of some other ideas like Pythagoras that are from other topics. Okay, so the first thing we're looking at is finding the area of a sector. Now, this is something that you hopefully have in your bound reference. So the formula that we're working with is A is the angle over 360 multiplied by pi squared. Now, the reason for this, just to remind you of the meaning of it, pi r squared is the area of a whole circle. Now theta over 360 is giving you the fraction of the circle. So if we had a semicircle, which would be 180 degrees, well 180 over 360 is a half. So you'd have half of the area of a circle. So all you've got to do in this case is just substitute things in, because we've got the angle and we've got the radius given to us, times, not equals, pi 5 squared. And so this is something you should do on your calculator. Now, one error that happened with this question was people who were looking at this and were trying to kind of guess this first part of the equation. And we're doing like a quarter of the area of a circle or something like that. I mean, if you know off the top of your head that 60 degrees is 1/6 of a circle, then definitely just do 1/6 times pi r squared. But our calculators are there to make our lives easier. So 60 over 360 times pi times 5 squared is not really very hard. And what we end up with there is 13.1 centimeters squared. Okay, calculate the area of the shaded annulus in the question below. Now, the thing that we've got to think about here, there's a couple of things we've got to think about. If we're trying to find the shaded area, which is, this bit here, what we're doing is we're thinking about composite shapes. So we've got a large circle, but then we've got to subtract the inner circle. And the other bit that they're going to confuse us with a little bit here is that we're not given the right dimensions here for the inner circle. So what we've got to recognize is if the radius of the outer circle out to here, the big circle, is 7 centimeters, but the thickness of the annulus here is 4 centimeters, then the radius of the inner circle is actually 3 centimeters. So that was one error, to use the wrong values in here. So basically what we've got is that the area, now we know the area of a circle is pi r squared, so the area of the annulus is just going to be the area of the big circle, so that's pi 7 squared, minus the area of the little circle, which is pi 3 squared. So you could do that in 2 steps if you wanted. There's nothing stopping you from calculating the area of one circle and then the other. But equally, you can always do these things in one calculation, and that's fine. So again, just doing it on my calculator, not really having to, work out anything else in my head, and I end up with 125, sorry, that should have been 125.6 centimeters squared. 19, calculating the total surface area of the rectangular prism. Now this one was an interesting one because it was kind of reasonably well done and kind of not that well done, because people didn't recognize that if you've got a rectangular prism, so we know a rectangular prism's got 6 sides, but the thing with this one is it's got 3 different dimensions. So we've got 0.4 high, 0.6 deep, and 1.5 long, or whatever you want to call it. What that means is that we've got one side which has the dimensions 0.4 and 0.6. So, that's kind of this side here has those dimensions. Now, if we wander down the other end of our shape, then this side here also has those dimensions. if we think about the top of our shape, well, it's 1.5 long and it's 0.6 meters wide. So we've got another surface here with that pair of dimensions, and that's the same as the one on the bottom. And then lastly, we've got one which is 0.4 high by 1.5 long, so that's the back side and also the front side of the prism. So we actually have 3 pairs of sides. What a lot of people did is they worked out the ends, and then they did like 4 times another combination of numbers as if it was really a square prism, I suppose, so with a square on one end and then longer sides. So you've just got to be careful with that sort of thing. Once you recognize that the area is of 3 pairs of sides, it becomes pretty easy. So because we've got pairs, I'm multiplying by 2, and then I'm just going to multiply the dimensions. So say I'm doing the red side first, so I'm going 0.4 times 0.6, so that's 1 pair of sides done. Then I'm going to add another pair of sides, so I'm going to do the, I'll do the 0.4 times 1.5 combination, and then the last pair is going to be the 0.6 times 1.5 combination. So now I've got all my combinations of the dimensions, giving me the 3 different sides. Each of those is multiplied by 2 because it's a pair, and we ended up with 3.48. Now everything was in meters, so that was pretty easy, meters squared. Question 20, I unintentionally made a bit harder than I meant to, but I don't regret that terribly, because when you are calculating the area of the triangular ends, you do actually need to know the height. Now, I forgot to tell you that. I forgot to give that value, but you can work it out by using Pythagoras. And this is the sort of stuff that you should be able to do. You should be able to apply some of those skills from other units. So I'm going to start off with that, and then we'll talk about the other part, which is relatively straightforward. So what I've got to think about here, one thing we know is, okay, it's 2 centimeters across the bottom, but because of this notation here, we're being told that each side is the same. So I'm going to use the back side here to figure out the height. Now, if I just draw a vertical line up my through the middle of that rear triangle, then I've formed 2 right-angled triangles. Now I know that the side length here on that long side, the hypotenuse of that triangle at the back is 2. I've cut the bottom here in half, so that means that is now 1. And so to figure out the height of the triangle, which is this quantity here, what I've got to do is just use Pythagoras. Now, using the short side formula, where if I want to find a, it's going to be the square root, whoops, that was a bit terrible, of c squared minus b squared. So all I've got to do is sub in my values here. So c is 2 squared, which is 4, minus 1 squared, which is 1. And so what we end up with is the height. A is the square root of 3, so the height of our triangle is, so the square root of 3 is about 1.73. Now, yeah, I want it as a decimal, not as a surd, just so I can get a decimal answer at the end. Now that I've got that, I can figure out the area of my ends. So the area of the ends, well, it's just a half of the base times the height, because it's a triangle, so it's a half of 2 times 1.73 is the height, and I've got 2 ends, so I'm going to multiply it all by 2, and what I end up with is, oops, I actually realized that I didn't work that out yet. That's about 3.46. Now we're talking centimeters squared for this one. So the area of the sides, now this is relatively easy, and I think I gave sort of half marks if people got some of this bit right. So the area of the sides, well, we've just got to recognize that they're rectangles, so that's just 7 times 2. So we've got the area of the sides there. But we've got 3 sides because it's a triangular prism. So 7 times 2 times 3, giving us a total of 42 centimeters squared for the area of the sides, which means that our total area is just those two numbers added together, 3.46 plus 42. We get 45 actually I think it rounds to about 45.5 centimeters cubed squared. Whoops, how embarrassing. Sorry, centimeters squared because it's area. Moving along. Calculate the capacity of 2/3 of the soup can correct to 1 decimal place. Now, again, this one's an interesting one, and part of the reason for this is I think this word may have thrown people a little bit. So the word in question is capacity. So what do we mean by capacity? Capacity is how much stuff something can hold, and how much stuff something can hold is the volume. So what we're saying here is another word for volume. Another clue there is you've got mils. So mils is a unit of volume. So, you know, we're kind of being told quite a lot of stuff here. Now, there's another part of it. They want 2/3 of the soup can. So they don't want the whole thing. They want 2/3 of it. But that's pretty easy. We'll worry about that a little bit later. Okay, so what else have we got? We've got 16 centimeters. Now, that is the height. Now down here we've got 9 centimeters is our diameter, which means that our radius is 4.5 centimeters. So the first thing we just need to think about is how do we find the volume of a cylinder like this, which is what the shape of a soup can. And all we're doing there is that we're going to do the volume of the soup can. Now remember, the volume of any right prism is the area of the base multiplied by the height. So we've got pi r squared is the area of the base multiplied by the height. Now we want to find 2/3 of the soup can, so we're just going to multiply that by 2/3. So then all I've got to do is substitute my numbers in. So pi times 4.5 squared times 16 times 2 over 3, and I'll just make that point a bit bigger, we end up with 678.6. Now you could write cubic centimeters here because you know, we're sort of starting off with centimeters as our unit of height and width and all that sort of stuff, and you've just got to remember that that is the same as 678.6 milliliters. So 1 cubic centimeter is 1 milliliter. 22. Now again, we've got to think a little bit about what we're being asked here. So we've got a tin, so we've got a cylinder again. We've got a label on it, but we want to make the label. So we don't really care about the fact that it's a tin. It could be any round thing. But what we're trying to find here is the area of this label that is going around the tin. Now, again, we've got some information here, but it's not all really stuff that we need to use, or we've got to think about it a little bit more. So it's 3 centimeters from the top. So this is 3 centimeters here, and 3 centimeters from the bottom, which means that our height or our width of our label is 14 centimeters. When we're thinking about what we've got down here, 12 is the diameter, which means that the radius is 6 centimeters. Now, when we want to find the area of a cylindrical surface, what we're doing is we're multiplying the circumference of that circle by that height. So our area is just going to be 2 pi r h. Actually, I could have just left 12 centimeters as the diameter. That would have worked as well. So I didn't really need to worry about the 6 part. So all I've got to do there is go 2 times pi times 6 multiplied by 14, which is the height of the label itself, not the whole tin, and we end up with 527.8 square centimeters. That's to 1 decimal place. Find the area of the triangle below in millimeters squared. Now this is another of the questions where we needed to think about Pythagoras. So the reason for that is to find the area, if this is our height here, then we need the base here, but we actually don't know what that is. But we do know that our hypotenuse here, the longest side, is 13, and our other short side is 5. So I can figure out what that unknown side is. Again, using my short side formula, a is the square root of c squared minus b squared. So in this case, I'm just going to say that the base value that I'm after, you remember as well, when you're doing your Pythagoras formulae, you can swap your a's and b's around. They really don't matter, because the only one that's important is the hypotenuse. Is the only one that's sort of special. Okay, so I'm swapping to b because I've got b in my diagram. So b is going to be the square root of, now I want my answer in millimeters squared, so I'm actually just going to work in millimeters from the start, and that will make my life slightly easier. So I'm going to do 130 squared minus 50 squared. And what I end up with is the nice convenient number of 120 millimeters, not centimeters. So then I've got my base. So to find the area, it's just a half of the base times the height. So it's just a half of 50 times 120, and we end up with 6,000 millimeters squared. Okay, last question. I want to design a rabbit hutch, so it's a triangular prism. We've got some dimensions and some information about it. So, and if I'm painting it, which is in the kind of, I want to paint the top sides and the ends. Now, this means we care about area. So we've got to, let's draw a diagram first, and then we'll kind of think about what the implications are of the area. So we've got a triangular prism. We've got now 1 meter long. Now I'm going to work in, what am I going to do here? You could work in centimeters first and then convert to square meters. You could maybe convert to meters first and then turn that into, convert all your units to meters first, and then you'll get your answers in square meters. It doesn't really matter. The only thing you've got to be careful with is that your conversions are okay. I'm actually going to stick in centimeters to start with, and I'll show you the conversion. So it's 1 meter long, that is 100 centimeters on that side. It is 40 centimeters wide and 35 centimeters high. So we've got 40 centimeters and we've got 35 centimeters there. Now what that means is I haven't actually told you what the height of these sides is. So, or not the height really, but the width of them, if you like. So we've got to use Pythagoras for that. So to figure that out, well, if it's 40 centimeters across the bottom, it means it is just 20 across half the bottom. So I'm going to use Pythagoras to figure out what this long side is. So it's going to be the square root of 20 squared plus 35 squared, and that gives us 40.3 centimeters as that side length there. Now the other thing that we've got to remember is that I've got to take away the circular hole that is in one of the ends. So if I put that hole down that end, Now, what do we know about it? It's got a diameter of 180 meters, which means it has a radius of 9 centimeters. That's a tiny decimal point there. I'll make that, that'll do. So then what have I got to work out? So I've got, I'm going to do the area of the ends. So I'm going to do the total area rather. So the area of the ends, well, I've got two ends. Now they're triangular, so the formula is a half of the base times the height. So that's half of 40 times 35. So that would be the area of the ends if there were no holes in it. So later on, I've got to deduct that the area of the hole. I've got two sides that I'm painting because it says here that I've got to paint the top sides and the ends. So I'm not painting the bottom side. So even though it's a triangular prism with 3 sides, I'm actually not painting this bottom side here. Yeah, doesn't matter what I'm doing with it, but I'm just not painting it. So I've got 2 times, now the dimensions of each side are there, well, they're 100 long multiplied by 40.3 is the dimension that we figured out earlier. So, and that should be a plus because I'm adding those together. So this is the total surface area of the top and the end, but then I'm cutting a hole in that, so I've got to take away the area of the hole, and that is given by pi r squared, so that's pi times 9 squared. So just quickly to review, I've got 2 times a half times 40 times 35. That's the area of 2 triangular ends, plus 2 times 100 times 40.3. That's the area of 2 rectangular sides which form the top, minus pi times 9 squared. That's the area of the hole. And so what we end up with is 9,207 square centimeters. Now, we want to work in square meters. What you've got to remember is that there are 10,000 square centimeters in a square meter because there's 100 centimeters in a meter, and so you multiply 100 by 100, you get 10,000. So the total area for one rabbit hutch equals 0.9207 meters squared. And the question is, how many rabbit hutches can be painted from a 4-litre tin of paint? So what we've got to think about is that the number of rabbit hutches is going to be oh, I realised I did this wrong the first time around. So 1 litre covers 4 square metres. So the number that we get with just 1 litre of paint is going to be 4 over 0.9207, which is 4.34 rabbit hutches per litre of paint. But we actually want to do a 4-litre tin, so we can multiply that by 4 again. So 4.34 multiplied by 4 is, sorry, I'm doing this without a calculator because I can't find it. So it is about 17. It's a little bit over 17, 17.2 or so. So 2 parts to this question really. The straight out area part, where you've just got to think about the information in the question and then what we have to do in terms of adding some areas and subtracting others, and then the last little bit, which is the problem solving question, thinking about, you know, how many rabbit hutches we get per litre and how many we get for 4 litres of paint. Okay, I hope this has been a bit helpful. If you are someone who is interested in improving your skills and possibly having another go at an assessment for the measurement area, this would be really good. Feel free to ask me any questions about this, and that can be email or in person or whatever. Thanks.